So today we need to discuss about this ETL, ELT, and ETL.
Mm,
So as you know, means nowadays we are taking a different approach. First, we will make a mind makeup, and then we will go to the theory. Am I right?
mm,
So, as its name suggests, means if we talk about the data life cycle. So in a data life cycle means inputs is required, means source is required from what is the origin or what is the source of our data. Am I right?
mm,
And after source means what is the processing or means what kind of transformation we require so
mm,
that we can utilize that data. Am I right?
mm,
And after doing that, how we are going to structure that data and how we are going to represent data. That's another thing. And last, when is done, when we are done with the how we are going to archive and when we are going to delete. This is the life cycle of our database
mm,
data. Am I right? So during this, when we talk about this E ETL or ELT. So means we are discussing means when means after means injecting after abstracting the data means our transformation required before means putting into a end destination. Maybe it's a file, it's a or NoSQL graph database things. Where am I right? This thing and apart from that sometimes you can think of when we require means we need means on a some Indian culture they means they give a more importance to the cleanness. Am I right?
mm,
And what they will do, they will means put a rack, shoe rack in front of their door. If that's indicating or they will indicating if you need to go inside that into this room or this house, then please keep your put your shoes here only. Am I right?
mm,
And they will use another you can say slipper or means other shoe pair inside the house only. So that means they can maintain the
mm,
cleanness. Am I right? So same thing here as well. Or some other culture they are not caring about this thing. They will say, "Hey, just you come up. Whatever you have, just come up." And inside the home itself, they have a mechanism to
mm,
do the cleaners. Okay.
mm,
So these are the things which means here you can think of when you are doing this means outside of your system or and you can say destination we are doing transformation beforehand.
mm,
Am I right?
mm,
And but here means this ELT we are saying just first you can come in. Okay.
mm,
And inside itself inside the system we have a mechanism which
mm,
will do this translation or transformation.
mm.
You understand?
Yes.
So here you can think of when you are saying hey this is a separate part, first we need to do the cleanup and everything
Mm,
outside our system or outside our house,
mm,
then that's a different means. You can use different tool there or you can use different means separate things are there. It's a loosely coupled. Am I right?
mm, mm,
Loosely coupled things are
mm,
there and there you can say means everything is have their own role. Am I
mm,
right?
mm,
So you have a better control.
mm,
And but if we talk about ELT, then ELT means you're saying you just come up and inside have we have everything. We have a
mm,
that mechanism with the help of that we can load and we can transform. Am I right?
mm,
So these and here you because when you need to manage a lot of things, then it's you can say you require more power. Am I right?
mm,
You are enough capable to handle everything. Am I right?
mm,
So system should be at in place.
mm,
So these things, if you know these things, then these two terms are easy for you, and
mm.
we will discuss these things only. What
Okay.
are the terms we used and things? Okay.
Mm. So,
If
in short, what you're trying. Okay, sorry. You. I thought
go
you.
ahead, go ahead, go ahead, go ahead.
No, no. So, in short, what you're trying to say, like with your example, ETL means like we will uh, first clean the data and then load, right? Just like
Yes,
the families which will allow. It's a really good example, Deepak. So I really liked. So some families will allow to wear the shoes inside, but inside they will allow them to wear some cover, or they will clean the. They will have some other alternate mechanism, right? So, but they will allow. So that is ETL.
yes,
And the other same example, like some families will not allow the shoes. That is, first they will say you come inside, then we will do the cleaning. So that is ELT.
yes,
Yes, ETL is just we leave your shoes outside, then we will then allow them. So extract, transform, load. Transfer is nothing but cleaning up the data.
yes.
Yeah,
Whatever you require,
yeah.
whatever you require, because
Mm,
there is no need to load unnecessary data
mm,
in our
mm,
system, because
yeah.
if we will do that, then memory cost is
Mm,
high, and
mm,
maintenance
mm.
cost is also high.
Yes.
So
So before
there you
load,
are. Yes.
before loading only we'll clean the data. Yeah,
Okay.
yeah. Okay,
So now go ahead.
right. With that simple and very relevant example, real world example, let's understand what is the goal. So the goal is to understand how data moves from source system to analytical system, and learn when to transform data before loading versus after loading, so that you can think beyond pipelines and move towards pipeline strategy. Yeah. So here we are just mainly thinking about how to load. It's we are not thinking about creating pipeline or we are. It's basically at high level. We're not thinking about designing any pipeline or anything. We're just mainly thinking how we can load, so we can build a strategy towards building the
Yes.
pipeline.
So
Yeah.
basically, as per our requirement, we will need to take a decision. We will need to take a decision. Is a candidate of ETL or just a candidate of ELT. You can say, you understand my point. Means it depend upon user requirement, user capacity, user constraint.
Yeah.
Okay,
Yes.
that's why.
Okay. Fine, Deepak. So, what is ETL and ELT? First, let's discuss about ETL. So, anyways, we know the. So, ETL stands for extract, transform, and load. Extract means extracting the data. Ingestion, we'll call. Sorry, ingestion, extraction. So then transform is nothing but we are doing the fine tuning, cleaning the data, removing the duplicate, those things, all those transformation operations. Load means just ingesting the data to the source system. So in this model, data is extracted from source system. Uh, just one line. You have to scroll up here, Deepak. Thank you. So data is transformed in an intermediate processing layer. Then the data is loaded into target system. Yeah. So in ETL, what we are doing, we are using an intermediate transform processing layer, right?
Yes,
That
yes,
is ETL. Next, coming to ELT, ELT stands for extract, load, transform. In this model, data is extracted from the source system. Raw data is first loaded into the target platform. So raw data is first loaded into the target system. Then transformations are executed inside the target system later. Yeah. Same example. We'll allow the guest to come inside wearing their shoes. Then we will ask them to, with some alternate mechanism, how we can maintain the cleanliness of our home. Maybe we'll give some alternate cover, or we will ask them to replace their shoes with the shoes which is worn in the home, shoes or slippers. Yeah, something like that. So one second, Deepak, one second. Scroll up, please. One more line. Yeah. In plain English meaning, both ETL and ELT are ways to move data from one place to another. Yeah, it is. It's just a data movement, right? So the real difference is the ETL. In ETL, you clean and reshape the data before storing in the final destination, right?
Yes.
So in ELT, you store a raw data first and clean or reshape it inside the destination layer. So it is
Later.
yeah, later we will do destination later. So we can understand that. Yeah. So next question is, why do we need ETL and ELT? Basically, the answer is to move the data, right? Let's
Yes.
understand here. Modern organizations have data spread across application databases there, ERP systems are there, CRM systems, log systems, CSV and Excel files are there, APIs, event streams, third party SaaS platforms. So data is available in these many places, right? So that raw data is usually in different format. Yes, inconsistent in naming, right? So it's inconsistent naming, duplicated, incomplete, not ready for analytical or reporting. Yes. Mm.
So you can think of whatever they are saying means if you talk about this means type of data means some system are storing in a CSV, some are storing in a XML, some are storing in a MongoDB, some are storing
Mm,
with this GraphQL or
mm,
not. You can say REST API. Some are using REST API, some are using GraphQL, some are using this
mm,
Neo4j and another database. Am I right?
mm,
So, or sometime data is same, but they are using different keys.
mm.
Okay.
Yes.
So for that we require transformation.
Mm,
So that we can transform in same
mm,
kind of data, and so it's easy for us to maintain and
mm,
use for analytics or other purpose.
mm. Yeah. Yeah. Agree. So ETL and ELT solve this by creating a controlled process to collect data from many systems, standardize structure and format, apply business rules, improve quality, make data analytics ready, feed warehouse dashboards and downstream system. Yeah, agree. So basically ELT or ETL will allow us to collect the data first, right? So we'll be able to collect the data from different system which we discuss, API, logs, dashboards, which we discussed, right? So we can collect the data from various source system, and we can create a standardized structure and formats how we can how we can store. So uniformity we can maintain by collecting the data and apply any business rules we want for reporting and all, and we can improve the quality like removing duplicate and uh, applying the strict data type strategies, like all those data quality checks can improve the qualities, make data analytically ready. Yeah, we can store that in a proper structured format so that we can create a reports. So these data can be fed into warehouse dashboards and downstream system. Yeah, understand all these points. Yeah, let's move to the third one. When should we use ETL versus ELT? This is the very important part of this topic. So use ETL when transformation must happen before data enters in the target. So our destination system requires the cleaned data, then we should use ETL, right?
Yes, yes.
So, for example, if our destination system is directly reporting, where, like for example, it's a warehouse where the reporting system are directly extracting the data. I mean, they are directly using the data. That time we should use dashboards, something we are feeding.
Analytics tool. Yes, analytics.
Analytics is a better word. Yeah. So if your destination system is directly linked to analytical systems like ETL, Power BI, sorry, what is it?
Tableau. Tableau.
Yeah, Tableau or Power BI, where the data is extracted, then we have to use this ETL.
Yes, you can even think of if you are going to represent to data, show a data to your layman person or
Mm.
end user, then it should be in a correct
Mm.
format.
Yes.
You cannot do the things in front of the user, clean
Mm.
up and other thing. Am I right?
Mm. Yes. Understand. Next point is the destination. But the second point I was reading, yeah, the destination system is not powerful enough for heavy transformation. Yeah, so the destination system is not heavy for transformation. So there we can't apply any transformation. Then we should be using this ETL.
Yes.
Okay. Sensitive data must be marked before loading. Yes.
Mask,
So,
mask,
sorry,
mask.
mask. Okay, okay, mask. I think increase the font little bit. I'm not using my spectacles. Maybe you can zoom. Yeah, this is better. Deepak. Yeah, thank you. So the destination system is not powerful enough for heavy traffic. Okay, sensitive data must be masked before loading. Yes, so we have to follow some governance like we had our in previous sessions, right? If
Yes.
the data is sensitive data and we have to honor the governance and all the any policies, then if we are presenting any, if other data is having any sensitive, then we have to use this ETL. Okay, like personal data or any customer personal information or any medical information, right? So that time any compliance the data needs to undergo, then we have to use this ETL. Okay. Data quality rules must be enforced early. So we have to enforce this data quality checks. So the data quality checks may be like constraints will apply, right? Integrity constraint. There
Yes.
should not be any duplicates and those kind of quality checks if you want. And the data should be like int like customer ID should be an int.
Data type
Uh,
should be there,
Data
length should be
enforcement.
there, it should be
Ah,
null or not null. Am
correct,
I right?
correct.
Those things
Yes.
are there, or you can apply a custom value as well.
Mm,
Means A should be for this particular A should be greater than this. So it
yes.
can be anything.
Yes. The age should be less than for so all those eligibility or any quality checks we are considering. So basically to have the cleaned data. So at that time we have to use this ETL. So
Yes.
legacy integration platforms are used. So okay, okay. When we are using legacy system integration, so that time also we need to enforce this ETL. Legacy systems, like if the existing system you are just moving the data to new system like on premises to cloud, maybe your legacy application is moving to cloud, that time also we have to use ETL. You
Yes.
want, yeah, you want tightly controlled curated loads. Yeah, when your goal is to have a controlled curated loads. Curated means like very cleaned transformed ingestion you wanted to do into the target system, then we need to use this ETL. So yeah, it's very good. So if I recall, if you scroll up the Deepak, so we have to use transform must happen before data enters. So before target transformation is required, that is our objective. Then we should use. And if the destination system is not efficient for transformation, that time we can use unsensitive data, mainly sensitive data quality. That time these 2 points is only mainly about the data. Second point is about the efficiency of the destination system. And
Yes.
yeah, maybe third is also we can consider about the data legacy platform. Okay, third
Privacy.
word. Yeah,
Privacy. Privacy.
yeah, privacy. Yes. The fourth, I think the last but one point is about the source system. If the source system are legacy systems, then we should think about ETL. And the last point is about again a data curated loads, right?
You can think of scalability and maintainability.
Maintainability
Because
also.
if you have a loosely coupling thing, then you can control better way.
Mm, yes,
If
yes, yes.
tomorrow you need to enhance something, then you need to touch upon this transformation layer. You understand my
Yeah,
point?
yeah, yeah. Okay. Use ELT when the other way. Use ELT when the destination is modern cloud warehouse or a lake house. ELT. The destination is a modern cloud warehouse or a lake house. Okay. So, right. So, if you are moving the data from on premises to warehouse, like modern warehouse, where we have lot of inbuilt features, right? That is why they are telling. So, don't worry about transformation and all. Everything will be taken care by these modern warehouse systems like lake house and snowflakes. So all these warehouse new warehouses, modern warehouse, they will take care of deduplicate, time travel, compression. Lot of features are there, right? So lake house features and all we can make use. So that is why they're telling when we are moving the data from when our destination is a lake house or a warehouse, modern warehouse, then we can. Yeah, that really makes sense, right, Deepak? Because
Yes.
we no need to worry about any transformation. Half of the transformation the warehouse itself will take care, built-in features, right? So I
So
think that is early.
ultimately, you can think of means a real warehouse in
Mm.
context of storing the different things. Am I right? Storing for
Yes.
6 months, 1 week, 2 days, 3 days.
Mm.
So they will maintain everything. They will
Correct.
maintain the temperature. They will maintain the, you can say, life cycle of that particular item.
Mm.
They are well trained. They are, you can say,
Correct.
well trained, and
Mm.
everything is organized based on that.
Mm.
Your different requirement. So those are platform or tools. You can
Mm.
use those. Am I right?
Correct. Correct. Agree. Okay. Next point, what he's telling is you want to preserve raw data for processing. You want to preserve the raw data for processing.
Reprocessing,
So,
not processing.
oh yeah, sorry, sorry, reprocessing. So when you want to preserve your raw data for okay. So for example, what he's trying to say, when we do ETL, we are transforming the data before we load. So that time we might I think disturb the existing data which is very valid. Data is very valid, right? So they don't want to touch the existing source data. They don't want it to disturb the existing data. So at that time they will use ELT. That's a very valid point, right, Deepak? So what they're trying to say, like if you borrow any if you're copying, like it's copying from your friend's book, like all the answers, and submitting, like, right? So but the ELT is the same thing, like you don't want to disturb your friend's answer. If it is wrong also, or if it is correct also, you're just copying as it is from your friend's book. And if you find any mistake, you can correct here within your book. So you don't want to disturb your friend's book. That kind of concept it is.
Or
So
you
which
can
is
think in a different manner as well, Ampaji. You can
mm,
think of right now you have a lake of you have a pool of data. Am I right?
mm, mm,
And you can say you can means one system require a different processing,
mm,
maybe another require different processing. So
mm,
you can reprocess that as well.
mm.
You understand my point?
Yes, yes,
Because you have a data source with you.
yes.
Raw
The
data is there.
original is there with us. Yeah.
So you can process. Or
Mm,
let's say tomorrow you require one more field. Am I
mm,
right?
mm,
Because it's a inbuilt. It's available with us only. You
mm,
can do that as well.
mm.
Understand my point?
Yes, yes. Mostly ELT are preferred, I think. Most of the project I have worked, I think those are all of ELT because of this modernized structure, and they wanted to have this original data without undisturbed. Yeah. Okay, Deep.
But it
Yeah.
depends requirement to requirement.
Requirement to requirement. Yeah, agree. Yeah. Next, third point that talking about large scale transformation are better executed inside the target engine. So when we have the large transformations, so like you wanted to not only checking the duplicate, or you are not checking about only the null values. If we have to do lot of transformation as per your business needs, so those can be executed better inside the target engines, like target systems, like modern warehouse, lake house. So they will have grown so strong that they can take care of huge data, big data, right? So very huge amount of volume of data they can handle. So that is why they are they that time we can prefer ELT. Yeah. Next point, analytics team want flexibility to build multiple models from the same raw layer. As you said, like we want to reprocess for variety of models. Like someone wants the direct report, or someone want to use the data for like prepare a RAG model. So someone wants to just prepare the reporting thing, or just wanted to prepare an FAQ model. So uh, they can reprocess the raw layer. So it will provide the flexibility. The original data is always with us. Okay. Okay, let's move to the next point. Compute can be scaled independently in the warehouse. Yes, as is, it provides scalability, right? The in the target system warehouse, you can scale up, scale down the computes, the cluster configurations, right? They are talking about that. So if the data is coming in the huge volume, you can increase the cluster size, and if the data is small, then you can reduce the cluster configuration. So that is the main important, actually. Very much cost effective steps. Yeah. Next, the last point is schema changes are frequent and processing is common. So reprocessing is common. So we, if the schema is keep on getting changes, like maybe you have 10 years of data and the data has evolved. If your table has evolved, if like in the first year they had a simple form where they had only 10 columns. Maybe down the line they have reversion the application, they have upgraded the application, they have captured additional information of the customer. So maybe now the table has grown to 15 columns. So then the schema will be evolved. If you're trying to load the entire 10 years data, so then you can find the schema mismatch, right? Like first year will have a first year table, the table employee table might have only 10 columns. Later in the down the line, in the fifth year data when you're loading it, find the five new extra column was added. So, and maybe we can anticipate in future also the date schema might evolve, like they might capture additional information, and the employee tables anticipated to grow. So at that time we can use the ELT. Yeah, good, Deepak. So think we are had enough discussion on that. Next, move to real life analogy. Imagine a restaurant receiving vegetables from multiple vendors. ETL analogy. Okay, ETL analogy, the vegetables are clean cut, sorted, and packed in a preparation room before entering the kitchen. Okay. That means the kitchen receives ready to cook ingredients. ETL. Yes. In the ELT analogy, the vegetables are delivered directly to the kitchen storage area first. Later, chef decides how to clean, cut, and prepare them depending on the dishes they wanted. Hmm. Okay. Lesson. Uh, Scroll down. Prepare before storing in final destination. ELT is store first, prepare later, where the work is consumed. Yeah, got that. Engineering view, a system design level. ETL and ELT are not just data movement patterns, they are decision about where transformation logic should live. Yes, exactly. It has to live in your source system before the source system or in the destination system. Where compute should happen, correct. Where should be your transformation logic engine, whether should execute it, and how raw data should be prepared, how the raw data should you want in the original form or you want in the cleaned form. Yeah, how lineage should be tracked. Lineage in the sense like the original data, how it has been evolved. So whether you want to track the lineage, how recovery and replay should work, how should you want it to have the data um, availability, whether you wanted to recovery or replay. So recovery means basically you can refer the original data and get the data back if there is anything happened to your data while transforming. If you uh, lose the data or if you get corrupted, the data corrupted, you can recover from the already loaded data. How that you want a replay means like you can replay and you can rerun the pipeline and get the data again. So that that also one of the strategy. And how team should own data contracts and model changes. Okay, right. So ETL architecture thinking. So how should an architecture think on the ETL? Typical flow: source system, extract layer, transformation engine, and target warehouse. So first source system will come, then extraction layer, then transformation engine. So ETL transform. So we are transforming before we are ingesting into the target. So transformation often happens in ETL tools, Spark jobs, Python jobs, integration platforms. So transformation usually happen in these ETL tools and Spark and Python jobs or integration platforms. Whereas in ETL architecture thinking, if you scroll down a bit, Deepak, on the ETL architecture thinking, typical flow is source system, raw landing layer, warehouse or lakehouse, then SQL or transformation is coming at the end, where the destination systems like lakehouse or warehouse system are coming before the transformation models. So transformation models often happens in SQL inside warehouse, DBT models, database models, warehouse native procedures, lakehouse compute engines. Yeah, so transformations are happening inside our warehouse and lakehouse system. Those are all the destination system. This is what we read right in the initial. Yeah. Next, let's compare both of them in the different areas. So first is transformation time. So it is before load. So here transformation is after load. And
Timing. It's a timing, no time.
yes,
Timing. Transformation.
timing. Okay, timing. Transformation timing. So when timing in the sense when we are doing the transformation. So transformations are done before in ETL and after in ELT. Right. So raw data preservation, yes, usually limited. In ETL, what we are doing, raw data preservation is less because we are transforming the data before we load, right? So we are cleaning up the entire data, so we can't get the original data. So the the data preservation is limited, but here strongly supported. You will preserve the original form, the raw data as it is, because we are having the copy of that as it is in the raw layer. Yeah, best fit. When it is best fit, ETL, legacy system, and strict control. Legacy systems you want to use, you want to extract, you want to work for data from the legacy system, and strict control. And then modern cloud analytics. So ELT is best suited when we have the destination systems like modern cloud analytics, like warehouse, lakehouse, those things. Then compute location, where separate processing layer is required here. But here the target is warehouse and lakehouse will already have this built-in compute locations. Yeah, they'll have the built-in compute power. And flexibility on ETL is less, wherein ELT is high. Yeah, the flexibility, like you can scale, or you can reprocess. So those things is very important here. Flexibility. Yeah. Reprocessing is like it is harder in reprocessing, whereas it is easier to reprocess because we are saving the original form of the data. Storage needed lower raw retention, where it is higher raw retention, because we are storing as it is copy of data, whatever the volume of data we are having as it is, whatever is there in the source system. Here we are maintaining that a copy. So that is why we have to compromise, trade off. Lot of storage cost we need to compromise. Next, come to analytical agility. So slower in the ETL, but it is faster in the ELT. Yeah. So we can, since the data is stored in the warehouse in the neat form, the curated form, so you can use any tools. And it provides a lot of flexibility and agility. Where governance needed, it's moderate in the ETL, right? So whereas we can high because raw data lands first. Yeah, can understand all those difference very clean. Okay, 7 ETL pipeline flow step by step. Extract. Step 1, extract. Collect data from database, APIs, flat files, SaaS platforms, logs, queues. Key concerns here is incremental extraction, change detection, API limits, source impact, authentication, and access. Step 2 is after extract, definitely E, that is extract, then transform T. So apply business and technical changes such as column renaming, typecasting, null handling, deduplication, yes, filtering invalid data, joining the references data, standardize currencies or units, right? Deriving metrics. Yes, Deepak, can scroll a bit. Yes, okay. So all those standardizations, transformations you are doing, then the key concerns are business rule ownership. Scroll a bit, Deepak, to please scroll. Yeah, data quality validation, transformation, versioning. Yeah, those are all the key concerns, and also error handling. Right, these are all the key concerns. Key concerns during the transformation. Step 3 is to load, where we have to move processed data into our destination system, data warehouses or reporting database, data mart, lakehouse, curated layers. Okay. So in ETL also we can load the data into data warehouse, modern data warehouse. Okay, okay. Data mart or lakehouse curated layer. Okay. Key concerns in the loading ETL is like full load versus incremental load. So whether you want to load full load or incremental load, how you want to do. Then merge or append strategy. You want to merge or append. Then item potency. Item potency is having the right data. I mean the data should not change.
To give a
Uh,
same result.
Same result. False data. Yeah, right result. It should give. Yeah, same result is the right word. And then later having records, performance and partitioning. Yeah. Then ELT pipeline step: extract, load, and transform. Extract data from source system with minimal changes. Load raw or near raw data into landing zone. Then browse raw schema, external storage or object storage. Then
External
transform.
state, external state.
Yeah, external stage or yeah, external stage and object storage. Either of this. Then the transformation. Run the transformation inside the target platform to build cleaned data, standardized business entities, facts and dimensions, and reporting tables. So everything we are doing inside the transformation. Yeah, could you please scroll down the pack? Hmm. So the advantage is the same raw data can be reused for multiple transformations. So our original data is available so that we can use it for other transformations. It's same thing like you are bringing vegetable. If it is chopped very small pieces, like for example onion. So if you chop it very small, so you can use it for some curries and other thing. But if you are cooking for say biryani or some pulao, so you need the onion to be cut in a different way, right? So it cannot be chopped so nicely, so it has to be little uh, bigger pieces, right? And if you wanted it has to use the onion for salad, you can use. So the onions are brought directly and kept into the kitchen, so the chef can cook chef can cut it according to the need.
Yes,
That's what the ELT is. Yeah.
yes.
Now let's understand batch versus incremental thinking in ETL and ELT. So full load. Load all source data every run. Yes. So useful when data set is small, system is simple, rebuild is acceptable, risk is very expensive, it is time consuming, it is slow, it is not scalable. Whereas incremental load only new change or changed data. Useful when data volumes are large, frequent refresh is required, and source system supports timestamps, change data capture, that is CDC, or version columns. Yeah. And risk is more complex logic, harder recovery, requires strong watermark strategy. Yes, that's the incremental load. Full load is just you can load it as it is. Yeah. 10 common transformation types: structural transformation, rename columns, split fields, lattice nested data, map data types, structural transform. Hmm. So we are just converting the data types, typecasting, and then we are doing the transformation, right? So split fields. Sometimes if the field is having multiple values, we're splitting the fields. Hmm. Okay.
Basically,
Flat.
we are playing with the structure.
Playing with the structure of the data. Yes, agree. Flattened nested data is used in the JSONs, like the data is stored in the flatten. Map data types. So we are mapping the data to with the relevant types. Okay, that is a structural strategy. Then data quality transformation. Yeah, remove duplicates, standardize code, handle missing values, and validate mandatory fields. Okay. So there we are just validating the data. Structural transform, data quality,
Quality. We are
quality,
considering a quality here.
quality transformation. Yes. Next is business transformation like revenue calculation, KPI derivation, customer segmentation, currency normalization. Yeah, all those are all business transformation. Structural, and then what is the other? Second one is the
So,
quality data. Yeah,
quality.
data quality transformation, business transformation, then modeling transformation, build dimensions, build facts, generate surrogate keys. Yeah, we all learned this in our previous classes, right? And create aggregates. So model transformation. Okay, okay. Really worth reading that one. Yeah. Real world cases. Use case one in e-commerce ordered analytics. Source order database. So use case one e-commerce order analytics. Okay. Source is order database, payment system, product catalog, customer CRM. Okay, then we need daily sales dashboard, product performance tracking, region wise revenue. Possible strategy here: load raw data and payments first, transform inside warehouse, then build fact, sales, and dimension tables. Okay. Banking compliance reporting. So here we will have source like core banking system is there, customer KYC platforms will be there, transaction monitoring systems. So these three might be our sources. We need strict validation. Yes. Sensitive data masking is there required. So and standardized regulation. Definitely we have to use ETL here. Next, SaaS product telemetry. So the sources may be application logs, event streams, subscription database. So what we need is yeah, product usage analytics, experiment tracking, retention modeling. Definitely we have to use ELT here. To we have to preserve the raw data, raw event, right? We can't modify that. Hmm. Pipeline strategy thinking. The goal is not just to ask, can I move data from A to B? The strategy question is, where should raw data land? Which transformation should be centralized? What should happen in ingestion versus modeling? How will we replay or recover? How much history should be preserved? Who owns schema change handling? How will batch and streaming coexist? Hmm. Strategic design questions. Before choosing ETL or ELT, ask what is the target platform capability? Yeah, we read right. So if the target platforms are inefficient to do the transformations, if they are not modern data warehouse system, we should not use ETL. We should use ETL, right? So do we need raw data retention? Yes. Do we need to preserve our original data, the raw data? I mean to say, how often does source schema changes? So whether the schema will keep changes or it is maintained. Like for example, the example which I took, the table employee, whether it is evolving throughout your 10 years of load. So how often the schema is changes? Then is compliance forcing preload masking? So are we going to mask any data? Are there any compliance? So that we need to think. Will many teams reuse the same raw data? So if there are multiple models we are building with the on top of the existing raw data, then we need to use about ELT. Then do we need fast experimentation for analytics? So do we need quick to market, and what is the okay, expected scale in 12 to 24 months? Mhm. Okay. Next, tooling examples. Second. Tooling examples: Informatica and Talent, SSIS, Penta, Penato, Apache Nifi, Custom Python or Spark Jobs, and ELT oriented tools. Those are all ETL oriented tools, Deepak. Can you just scroll? Yeah, ETL, extract, transform, load oriented tools, Informatica, Talent. Okay, okay. These tools are allowing us to transform the data before loading. Yes, yes, SSIS is on hard thus. Yeah. Then ELT tools are like Fivetran, Airbyte, DBT, native warehouse, SQL pipelines, Snowflake, stars constraints, BigQuery, scheduled queries. Yeah, these are a load test. Okay. Important note: a tool does not permanently belong to one side only. Many modern platforms supports hybrid patterns as well. Okay, okay, okay. So means the same tool can support both ETL and ELT. Mm,
Yes.
okay. Minimal. Are we on time, Deepak? Or okay. Minimal technical examples. ETL pseudocode, extract order from source DB, transform, remove, cancelled report, standardize order data format, join custom regions, calculate net amount, load it into the analytic dot sales fact. Okay. Whereas ELT pseudocode, can you just scroll up, please? Extract order from the source DB. Here, load the raw data into the raw orders, transform inside the warehouse. Right. So here we are transforming the table. Create table, curated sales fact as select amount discount from raw dot orders, where status is not equal to cancelled. Okay. Hmm. Okay. Next, SQL transformation in ELT. Create or replace table curated dot daily sales as select. Order date reason. Some net amount as total sales. Count distinct order ID as total orders. From curated to sales fact. Group by order data region. Okay. 15 is a common mistakes. Mistake 1: treating ETL and ELT as only definitions. Yeah, many learners memorize the expansions but do not understand the architectural trade-offs. Yes, loading raw sensitive data without governance. Yeah, we are just loading the raw data without governance. Like ELT can create compliance risk if masking, classification, and access controls are weak. Right. Over transforming too early. Over transforming, like they will sometimes over transform. If every rule is backed into ingestion, future changes becomes expensive. Yes. Mistake 4 is ignoring replay strategy. Pipeline fails in production if replay is not designed. Trust in data platform drops. Yes, definitely. We will think that the production will not fail, but sometimes if it has passed in dev, it is passed in QA. Sometimes in productions, it's expected to fail. So we should have the capability to replay the pipeline. Mixing business logic everywhere. Transform logic scattered across Airflow, Python, SQL, and dashboard becomes unmanageable. Mistake no idempotency. Like rerunning the same job should not duplicate result. Mistake no schema change plan. Yes, deep concept you should understand is idempotency, whereas running the same pipeline again should produce the same, correct, as you said. Yeah, same result it should come. Lineage, you must know where each fields come from and what rules changed it. Yeah. Watermarking is incremental processing, depends on tracking and last processed states such as timestamp and sequence number. Yeah, watermarking. Raw versus curated layer. Raw layer preserves source truth. Curated layers present business ready truth. Yeah. Late arriving data may arrive after the expected processing window. Pipelines must handle it, so it has to will include introduce wait strategy there. Yeah, data contract awareness. The producer and consumer should align on schema, field meaning, and change expectation. Yeah, we will always coordinate with the source system. This is what we are doing. Okay, rest all is for self studies. Okay, yeah. Mhm. So, quick recap what you learned. ETL transforms before load, ELT transform after load. The real difference is not wording but architectural placement of compute and logic. ETL is strong for controlled preload processing, whereas ELT is strong for modern analytics flexibility and raw retention. Yeah, we can understand all those things. Strategic thinking requires considering governance, replay, scale, and future changes. Final interview line ETL and ELT are just integration pattern. The They are architecture decisions about where data should be transformed, how raw data should be preserved, and how the platform should scale for governance, analytics, and future change. Yeah, great.